हेलो बाहर से बंद कर दो हेलो गुड आफ्टरनून स्टूडेंट्स in the last lecture we discussed the how we multiply two 32-bit number and produce a 64-bit result, and this is the basic algorithm we discussed in the last lecture. In this, if the LSB of v is 1, then we will take care, otherwise we will not take care. Then first we addition, then we multiply, and last we arithmetic right shift. Then how this algorithm work, we take with example. Let's suppose here we multiply 3 into 2. Then as discussed in the algorithm, all the bit of u is 0 and we have the multiplier. In the register b 0 0 1 1, and in the u all the bits are 0, and we take one extra bit for to check the overflow. Then before shift, if the LSB of v is 1, here LSB of v is 1 in the starting 1, then we simple u equal to u plus n. So n is the 0010, then we simply add it, then it becomes, if we add 10 to 00, then it becomes 0010, and it is 0011, and we simply shift, right shift in every iteration. Then one thrown out, and this one is comes here, and this 00 either, and this 0 comes here, and this bit 1 come here, and likewise this is 0. Then next again we check the LSB of 1. If the here again the LSB of 1, then we simply add to it, then 2, or here is 1, so 2 plus 1 3 means double 1, then we simply 00011 means 3, 1 plus 2, then it is 0001 like above. Then simply shift it, then this bit is thrown out, 000 comes here, and this one shift to it, and this one comes here, and this, then we again check the LSB of 1. Here LSB of v is 0, then we do nothing, then simply comes here and we shift this operation, then 0 0, and here 1 here come, and 1 here, and again all the bits are 0 in the last. Then we again we check the LSB of v is 0, then we do nothing, simply we shift it, then 0 comes here, this 0 come here, the 0, and either 0, and in the because 3 is a 4-bit multiplication, then in the case of we take only 4-bit iteration. In the 4-bit iteration we get the result 0 111 in the 1110 means this is simply 6, and 3 into 2 it is a 6. This is how the algorithm works. Let's take another example for to multiplicand with the negative. Let's suppose multiplicand is the 30011, and multiplier is -2. So -2 first we represent in the 2s complement. So -2 means 16 minus 2. 16 minus 2 is the 14. 14 is 8 plus 4 12. 12 plus 2 1. 12 plus 2 14. 1110. So this is 1110. Then again u and v have multiplier 1110, and you have all the bit 0 and one extra bit. Then before shift, first we check the LSB of v. V is 0, then we do nothing. Simply write this, and with shift, then 0 is thrown out, and 1 come here, and this 0 come here, and this bit is 0. Then we again check the LSB of v. Here now the LSB is 1. Then we simply add multiplicand. So here multiplicand is 1 1. So simply it becomes 0011, and this is like this 000111, as simply shifted, 1 is thrown out, this 011 comes here, and 1 come here, and this 1 come here, and all the bits are 0. Then we again check the LSB of V is 1. Then we simply add multiplier, then 3. Then here is 1, 1 plus 3. 1 plus 3 means 4. 4 means 0, 0, 1, 0, 0. And here 1, 0, 1, 1. Then simply subtract 1 thrown out. 1 comes here, 0 comes here, 1 comes here, and this 0 come here, and this 1, 0, and this 1. Then we again check the here. Now if the in the last iteration, in the just before the last iteration, if the LSB of V is 1, then we simply in the last iteration we don't add, we simply subtract. But in the positive number, this bit is always 0 in the third iteration for to check the 4-bit number. But in the case of negative number, always there is a LSB of V is always 1 in the case of negative number. Then in this case we simply subtract. Then subtract means 1 0 0 0 1 0 minus 3. तो 1 0 minus 3 means क्या हो गया 2 minus 3. तो मेरा क्या हो गया बेटा 2 minus 3. 2 minus 3 means minus 1. minus 1 को जो हम 2s complement में represent करेंगे तो it becomes 1 1 1 and this is a sign extension. 4 times 1 is the minus 1 and 1 is a sign extension. So this becomes 1 1 1 1 and this becomes 0 1 1 0 and again shift the 1 thrown out. This becomes 0 1 0 and this will come here and sign extension, and this is 1 0 1 0. 1 0 means 8 plus 2, 8 minus 2. 8 minus 2 means minus 6. So this is how this algorithm works for two positive number and negative number. In the case of positive number, in the third iteration, this bit becomes 0, but in the case of negative number, this bit becomes 1. When this bit becomes 1 in the third iteration means number is negative, then we simply subtract it. But in the last example, this bit becomes 0. So in this algorithm, simply take a look. We check always LSB of V. If it is 0, do nothing. If it is 1, simply add n, multiplying to it. Or right shifting the partial product is same as the left shifting. We need every step. Last step is different. In the last step, if LSB of V equal to MSB of V, or if 0, do nothing. Or यदि 1 है तो means क्या? Multiplier is negative. So negative means क्या है? Like we discussed in the last class, in the number is represented into a 1 to n minus 1 minus 2 की power n minus 1. So here simply in the case of negative number, we simply negate it like this formula. So there are n loops. So each loop legs or log n times, and total complexity of this algorithm is O n log n times. Then in the case, next is the Booth multiplier. Then what is the Booth algorithm? So Booth algorithm is same as the iterative multiplier, but it is some by the asymptotic notation. Both takes the same time, but in the if we check the like the CPU time and in the case, so Booth algorithm is some much faster. And then how it is possible, then we simply discuss here. In the Booth algorithm basically designed for the when we have a sequence of simply continuous sequence of 1, means let's suppose this is a 0 0 0 0 0 and then in between there is a 1 1 1 1 1 1 1 1 and last that is a 0 0 0. In this case, in the case of iterative multiplier, we simply shift this one, shift, let's suppose 1 is j times, then is shifted the j times. But in the Booth multiplier, according to Booth, this simply say when we switch from the 0 to 1, when we switch from the 0 to 1, we simply negate here, or when we shift here again 1 to 0, then we simply add here. This is the simply concept of both algorithm. Simply, if the previous bit is 0 and next bit is 1, then we simply negate number. If the previous bit is 1 and current bit is 0, then we simply add here. So if we like this, if we shift 111 to the right, then this becomes 2 k power j plus 1 minus 2 k power right, like it is a GP summation. So in the how this operation in this simply we check the bit pair in the multiplier, current bit and previous bit, and we take action based on the bit pair. Let's suppose previous bit is 0 and current bit is 0, then we simply do nothing. All the bits are 0, then we do nothing. In the like the iterative multiplier algorithm, if the previous bit is 0 and we comes into the 1 1 1, let's suppose this is a number 0 0 0 0 1 1 1 1 1 1 1 1 1 and again 0 0, then first if we current bit is 0 and next bit is 0, then we do nothing. If we current bit is 0 and next bit is 1, then we simply subtract here, subtract multiplicate, or in between the 1 1 1 we do nothing, and we again went to go to the 1 to 0, then we simply add multiplicate. This is a basic booth algorithm for to multiply two 32-bit number to produce 64-bit result. Like in the iterative algorithm, multiplier in V, and you have all the bit 0 and multiplicand is n. Then first I 0 assigned to I and previous bit both are 0 0 and when with the thing, and for I less than 32 I equal to I plus 1, and we check the current bit of LSB of 1. If the current bit and previous bit are 1 0, then simply subtract it. Else if the current bit previous bit is 0 1 pair, then we simply add it and we simply arithmetic right shift. Then we see simply take an example of it. Let's suppose multiplicand and 3 into 2, then likewise u is 0 and v is the multiplier 00 10. The before shift, this becomes we check the LSB of v, it is 0, then and the previous bit we take it 0 0, then simply it is a 0 0 pair, then 0 0 pairs we do nothing, so simply shift it, then 0 become thrown out, then become 1 0 0 0. Then we again check the LSB bit is 1 and previous bit is 0, then it become 1 0 pair. So 1 0 pair means, yeah, here we simply subtract, so subtract 3. तो subtract 3 means क्या हुआ, या भी वे किससे add -3, तो add minus 3 का मतलब क्या हो गया 16 minus 3, तो 16 minus 3 equal to 13. तो 13 means क्या हो गया, represent it 8 plus 4 plus 1 13, and 1 is the sign extension, and this becomes 1101 and it is 001, and simply right shift, then 1 thrown out, 000 comes here and this 1 come here, then this 0 come here and 1 1 and this sign extension. Then we again check the LSB is 0 and previous bit is 1, then it becomes 0 1 pair, then 0 1 pair means simply add. So add, then we simply add 3, so this becomes simply 1. So 0001 100, then again right shift, this 0 thrown out and this 1 comes here and this is 1100. Then again we check here LSB of 0 and previous bit is also 0, then do nothing, so simply 1100 and this right shift it, So we get the result 0 0 1 1 0. Then this is the final sum. Then this is example of how the Booth algorithm work. So Booth algorithm is changed only in the like the iterative multiplier algorithm in the two case 1 0 and 0 1. In the 1 0 case simply subtract, and 0 1 case in the we simply add it. So how this algorithm work? So both have the same time complexity, like in the negative case. So complexity is O log n per time. So this is the basic introduction of the how the multiplication is done in the computer organizer. Okay, beta. Thank you.